Hello class, this is a video tutorial on factoring polynomials. Coming full circle to all of this, in the very beginning we asked the question of how it would be possible to factor any polynomial of any degree into, for example, an expression like this, how can we factor it to become something that looks something like this? So this is answering that question now. For any polynomial p of x and factor x minus a, p of x can be written as p of x equals x minus a times q of x. Now, the value of a can be figured out as one of the factors of the constant of p of x. I'll demonstrate that to you in a moment. And if p of x has degree n, then the polynomial has at most n real factors. So if it's degree 3, we can factor it into 3 brackets. That's what this last statement means. So let's do an example here. The first one I've already kind of set up. The constant term of the polynomial is negative 12. So the factors that we need to test are plus or minus 1, plus or minus 12, plus or minus 2, 6, 3, and 4. So one of these numbers, or 3 of these numbers possibly, where if we divided it by, let's say, x minus 1, the remainder of this should be 0. If that is true, then x minus 1 is a factor, and we could write it as x minus 1 times q of x. And then from there, we're going to divide this even further because it is yet another polynomial. I'll demonstrate to you what I mean here. Using your calculator, I want you to substitute the values of 1, negative 1, 2, and negative 2 into our polynomial. I'm going to use my physical calculator here. It's a lot faster. 1 cubed plus 3 times 1 squared minus 4 times 1 minus 12. You should get negative 12 for this. So 1 is not a factor. Let's try negative 1. Just changing the negative. We get negative 6. Also not a factor. Let's try the value of 2. That gives me 0. So 2 is a factor. That means if we divide this polynomial by x minus 2, we would get no remainder. So let's do that now. Using polynomial long division, or in this case, I'm going to use synthetic long division. So 2 becomes my divisor. Taking the coefficients and doing our synthetic long division. Ignoring the first, multiplying, adding, multiplying, adding, multiplying, and adding once more. We get a remainder of 0. Now remember, because the power is 3, our quotient is always going to be 1 power less, with a remainder of 0. So that means p of x, our original dividend, this can be written as our factor times our quotient, x squared plus 5x plus 6. Notice how we've written it like this. And now we could repeat the exact same process here, but thankfully we know how to factor quadratics a lot faster. So this can be further factorized into, just think of 2 numbers using 6 and 5. I'm getting x plus 2, x plus 3. So p of x fully factorized is this expression here. And we could apply this to higher degree polynomials, but for now let's stick to a degree 3. You can pause the video and try it yourself. And here we go. Our constant term is 15. So the factors we should be testing are plus or minus 1, 15, 3, or 5. Using your calculator, let's just test these numbers. P of 1, P of minus 1, P of 3, P of minus 3. I tend to test the smallest numbers and hopefully I get something good there. Testing 1 cubed, plus 3 times 1 squared, plus 5 times 1, plus 15. That definitely doesn't work. They're all positive. Trying negative 1, negative, negative. I get positive 12. So these two don't work. Let's try, well, just looking at this, we know positive 3 won't work because these will all be positives. So we get a very big number. So I already know that's not going to work. So let's try negative 3. Let's see what we get. I get 0. That there is a factor. So if it's negative 3, it's going to be x minus a. And since a is negative 3, it'll be x minus minus 3, which is x plus 3. That's going to be our divisor. Let's copy this. Oops. And let's get rid of a few. And let's erase what we need. So negative 3 is going to be our divisor. Taking the coefficients, we get 1, 3, 5, 15. Ignoring the first, multiplying, adding, multiplying, adding, multiplying, and then adding. As always, we just take decreasing powers. So that means p of x can be written as, we had x plus 3 times our quotient here. So x squared, 0x is just 0, plus 5. Unfortunately for this is not a polynomial that we can factor using regular means. So this is a fully factored form of this expression here. So now that we have seen how to factor degree of 3, we'll take a look at, in the next video, factoring higher order or higher degree polynomials. So I hope that gave you an insight into factoring polynomials. I'll see you in the next video. Best of luck.